In this section, we're going to cover loops. So loops are a very powerful way of not repeating code multiple times. Let's jump straight in and get an understanding of what loops are and how useful they are. There are two different types of loop, deterministic and indeterministic. Quite simply, deterministic loops are defined by knowing at what point the loop will complete. We can determine the state when the loop will finish. An example of a deterministic loop is as follows. We will use the arrays from our previous examples for the purpose of this demonstration. Let's say we wanted to print out all the values contained within a cookie jar array. We could do the following. I will create a new file to contain the code that we're going to use for this and call it loops. And we must change the text extension to .py. Yes, and now when we open this with Notepad, we can enter in our commands. So cookie jar equals cookie 1, cookie 2, cookie 3, and then we close off the array. On the next line, we will type out print and then cookie jar with the index of 0 for the first cookie. Next line, we will type in cookie jar and then index 1. For the second cookie, and for the third and final line, we will use cookie jar and the index of 2. So if we save this and we run this in our command line interface, so py loops.py, and you can see it comes out with cookie 1, cookie 2 and cookie 3 just as we type them out in the code. If you imagine how painful it would be to have to type this out if you had 100 cookies, even copy and pasting would take a long time. Plus, if we wanted to change the name of our variable from cookie jar to cookies, we'd have to go through all references to cookie jar and change it to cookies manually. With a loop, we are able to write 2 lines of code to achieve the same result. How great is that? Try replacing the code from this example with the following. We'll remove the print lines and put in a for loop. Here we're effectively taking the cookie jar array from above and creating a temporary instance for each run of the loop called cookie. So within the loop here, you can see we've tabbed across one space. That means anything we type here now will run in the loop. So if we type print cookie and save, if we go back to our command line and run the same file again, you end up with cookie 1, cookie 2 and cookie 3, but you haven't had to manually type out all the print statements. So just as an example, we will add another cookie to the jar, save and rerun in the command line interface. As you can see, there are now 4 cookies. So just as a reference, the first time, if we were to run through this code hypothetically, we've assigned cookie jar 4 cookies. We get to the next line. In the for loop, the first time cookie is brought up, we are bringing the first cookie from the cookie jar, which happens to be here. And then we take that first cookie and print it out to the screen. This is a deterministic array and will loop 4 times because there are 4 items in this array. Let's break down exactly what's going on here. The for part of the loop statement, this tells the Python interpreter that we are going to want to loop through something. The cookie part, each time the loop goes around once, it moves on to the next item in the cookie jar array and picks up the next cookie. Therefore, the first time we enter the loop, cookie will have the value of cookie 1. The in statement is an operator that tells the Python interpreter to assign the value of cookie jar each time the loop goes around. We know what the cookie jar is, an array. So for our next example, we will cover indeterministic loops. Let's say we cannot determine at what point a loop might exit. We have no way of using a for loop to capture this event. Cue the while loop. To elaborate, the following example allows us to keep looping until we come across cookie 2 in the cookie jar array. We'll change our code to represent the following. We'll create I as a variable and assign it a value of 0. This will be used as our reference or an index. We will then create another variable called found and set this to 0. This will be used to indicate to the loop when an item has been found. The next line, we will use the while command, which is our indeterministic loop. So while found is equal to 0, we want to loop through. The next line, we'll use a tab to indicate that we want to execute commands within the loop, and we'll type print cookie jar and then I. The next line, we'll use an if statement to say cookie jar index. If this is equal to cookie 2, then on the next line within this statement, we want to tab across again to execute found equals 1, and we will call up the break clause. At the end of this loop, we tab back one space. This will not be executed under the if statement, and it indicates the end of the loop. We will increase our index by 1. So in this example, if we save this and go back to our command line interface and run the file loops again, we will go to cookie 1, cookie 2, and then once it's found cookie 2, we can also add in a print statement that says cookie found to indicate to the user that cookie 2 has been found. As a side note, if we were to change this cookie 2 search criteria to have a space at the end, have a look to see what the result is. We get list index out of range because after the first 4 cookies have been searched through, the while loop hasn't yet found cookie 2 because it hasn't matched up this due to the space. So it has gone on past cookie 4 within its loop to try and find another item in the array, but it's returned back the same error as we had previously in another video, list index out of range. So effectively, it's tried printing out an index of 4, which would have been cookie 5. So starting at 0, 1, 2, 3, 4, we've run out of cookies to search through. This is quite an important point because sometimes a small space can be the difference between a program running properly and it not. When debugging and troubleshooting, it can be very frustrating, but if you take the time to go through your code and check it through, you may find mistakes like this. It might lead to quicker resolutions. You can also get a peer to check your code as a sanity check. This is very useful, especially in the real world, because it can save a lot of time.